Yeah, good evening, everyone. Switch on again. Let's start off. This was the last thing that we did. Next thing. So we have a function here, x is equal to 5 sin omega t plus 5 root 3 cos omega t. Find amplitude and phase angle. So function, right? Displacement of an SHM is given by 5 sin omega t plus 5 root 3 cos omega t. Let's see. Now, one way to do this thing, right, is completely mathematical. You can, you have done this in maths. You can take out a pi common here and you can write this thing as sin omega t half plus root 3 by 2 omega t into 2. Then this can be written as sin omega t cos 60 sin 60 cos omega t, and then this becomes sin omega t plus pi by 3. So from here you get the amplitude is 10 and phase angle is pi by 3. So this is all good and nice for two functions. But the problem is, what if you have multiple things? Then this becomes a problem. So we have a technique for this. We call it, phasor method. We're not going to the exact proof, why it works, how it works. We're not interested in that. But let's see what is the method. This actually comes from, complex numbers. So basically in phasors, what we do, we treat the amplitude like vectors. Magnitude of vectors at an angle. See, let's take a general function. X is equal to a sine omega t plus b sine omega t plus phi. Logically, what is happening, if you think about it, remember how we defined SHM as two particles going on a circle. So if you actually treat them as two particles going in a circle, you will observe there is one particle here A, there's another particle here B, and this angle is phi. Now, since both are rotating with omega, no matter how much they rotate, won't this angle, this two vectors won't remain same? After some time, they will rotate and the diagram will become like this. A will come here, B will come here, but this angle will still remain phi. Is that making sense? So we can treat them like two vectors, and this is how it works. So take it, because the phase angle is 0, take A as this way, phi is 0, and take B at an angle phi. And then you know how to do the resultant for these two. This will become A plus B cos phi, and this will be B sin phi. The resultant of these two vectors is R, and let this angle be alpha. So from here we can write R is equal to root over A square plus B square 2AB cos phi. And that angle tan alpha will be B sin phi. This comes from parallelogram of vectors, or you can actually square them and add them. B sin phi plus A plus B cos phi. So you can write this function x is equal to R sin omega t plus alpha. So this whole function becomes like this: R sin omega t plus alpha. This is a technique, to convert multiple sine or cos functions into a single sine function. The only drawback of this method, it works only when valid. R is amplitude here. Alpha is your phase angle. Valid when omega is same. If you have different omegas, it's not an SHM. Please have a look at this. This method is quite useful when you're even dealing with multiple functions. So no matter how many functions I give, you can just treat the amplitudes, as the vectors, and the phase angle as an angle with the horizontal. Add them and you're done. So let me take an example on this. Let's say x is equal to 20 sine omega t, 20 root 2 sine omega t plus pi by 4 plus 20 cos omega t plus 25 sine omega t plus 37. So there I can keep giving more and more. Find amplitude of this function. So phasors is quite useful when you even have multiple functions. Very useful thing, phasors. We're going to use this again in waves, wave optics, alternating current. This concept totally comes in 4 different chapters. Simple way to understand is, think of this circle. We have two particles on concentric circles, both going with same omega. No matter how much these two things rotate, this angle will always remain same. So indirectly, what you're taking is a resultant of these two, something of that sort. What you're getting is a resultant which is rotating on a new radius with a new angle alpha. Making sense? It kind of looks like that. Let's get this. So let's treat them as vectors. So first thing is 20. Next thing, 20 root 2. This makes an angle of 45. Then we have 20 cos omega t. That is 20, 90 degrees. That is one more 20. And another is 25. 37 degrees. So basically 4 vectors. So just resolve them horizontally. You end up with 20, 25 cos 37, 20 root 2 cos 45. Vertical direction is 20. 25 sine 37, 20 root 2 sine 45. Perfect. So how much is this? If I add this, that will be 20 cos 37 is 4 by 5, 20, 20, 60. This guy will be 20, 20, 55. This is your resultant and this is your alpha. So R is equal to root over 55 square plus 60 square. Alpha is tan inverse 55 by 60. So you can write this function as x is equal to a sine omega t plus 5. Check. Easy. You just need to convert everything into vectors and they look the same. It's easy after that. Doesn't matter how many functions I give. Clear? Next thing. Any doubts on this? Simple one. It is just vectors. There's nothing there. The main idea is that you can write 20 cos omega t as 20 sine omega t plus 90. So that's how I got. So basically convert everything into sines or cos. Then you see the angles. This thing has 0, this thing has 45, this thing has 90, and this thing has 37. So you have 4 vectors of different magnitudes and different angles. Get I cap, j cap, and you're done. Let's see another type of this. Let's say we have position vector r bar, which is a sine omega t I cap plus b sine omega t j cap. R bar a sine omega t I cap plus b cos omega t j cap. Meaning this kind of motion, right, can occur when you connect a block with 2 springs. So this spring is making you oscillate in x direction. This spring is making you oscillate in y direction. Small oscillations. Find the amplitude. So in case of phasors, right, you can add them only when they're in the same line. How do we handle this? Think. See, if you actually observe what is happening here, look at the first one. The x coordinate is a sine omega t. So this is the oscillation in the x direction. The y coordinate is b sine omega t. So if you just divide them, you get x by y is equal to a by b. So what you get is equal to y a b by a x. That means this block and system which is there, the meaning of that function, right? Both of them are starting from their respective mean positions. Meaning in x direction it's at the mean position, in y direction it's at the mean position, and the motion is going like this. The particle is actually going in a straight line. They can ask you the trajectory also. In which part does the block oscillate? It's a straight line. And what is amplitude definition? Maximum distance from the mean position. So on the horizontal direction, you travel a maximum distance of A. Vertical distance, you travel a maximum distance of B. Therefore, amplitude is root over A square plus B square. Is that making sense? Now can you do the B part? So if I moment I say I cap, J cap, I'm talking about two different springs. In this previous case, it is like all the SHMs are superposed on the same direction. We all are in the same X direction. If you see, all are giving you X coordinate only. So be careful. You can use phasors only when all the things are in the same direction with the same omega. This is like vectors in SHM. What about the B part? Who is getting disconnected? Why so many people are missing today? Look at the second one. We get x is equal to a sine omega t, meaning in the x direction, you're starting from the mean position. Y is equal to, so if you see this is x square by a square plus y square by b square is equal to 1. This thing is actually going in an ellipse. Meaning, if you look at the motion now, it is something like this. It's going in an ellipse where t is 0, x is 0, but y is maximum, isn't it? It's like this. It's kind of like this. At t0, your x is 0. At t0, your y is maximum. So it is going in an elliptical path. This is your initial position. Then y may you're at the extreme. In the right side, in the x may you're at the mean position. Clear? So basically it will go in an ellipse. It will be a small ellipse. Basically, I exaggerated the figure here. We are assuming the springs are almost, they're not bending too much. So it's actually kind of a small ellipse here. Clear? So you can get different paths like this. You can get even more weird paths. Let me show you how those look. When you're in electrical, na, IIT lab, mein, you actually get to do these things. They'll give you some function generators and you can create all these kind of functions. So it'll be root over a square plus b square, the maximum distance from the mean position. Or you can take it as, if you're starting from here, whichever is what is the maximum distance here? So what is the mean position here? Mean position is this guy. This is your starting point. So basically you can say this is your amplitude, which actually looks again root over a square plus b square. Actually, the mean position would be something like this. This is your mean position. So between A and B, whoever is bigger is the amplitude. Okay? Mean position is when both x and 0, right? The force is 0. So basically it got oscillated in the vertical direction and the left mate is moving. So here between A and B, whoever is maximum, A or B, whoever is big. So if you look at this figure, right, this is the same function there, what I just now wrote. X is equal to A sine omega t, this is the general function, I cap, plus B sine omega t plus phi. Generally in 11th and 12th, they don't go beyond, the phi 0 and the phi 90, the two cases I taught you. This will be the ratio of A is to B. So I can change A and B ka ratio, and this is the different phase angle ka constants. You can see what all weird shapes you get. So these things have a name. These are called Lissajous figures. Meaning if you take A is to B is 1:3 ratio, and if you take the phase angle as 90, you'll get this kind of shape. The block will actually go in this way oscillation. So if you're in electrical department, we'll have something called an oscilloscope. There we actually have a small electron beam which will create all these kind of paths. So we can apply voltage in x direction and y direction, and you can do something like this. So one of the assignment was, examiner, they asked us to find this guy. This was the assignment. You have to build a circuit which will give you this. You have only voltages and you have to build a circuit to get this. And 2.5 hours was the time. I made this. I was going and showing everyone, dekho, mera, what did I make? Karke. And the teacher told to come again and repeat next day for another 3 hours. So you have to do the assignment what is given. You can't do whatever you want. I really don't know why I got that also. Clear with this? Phasors is very important, getting it, because it will come in 3 more chapters and quite a useful concept. The next thing. Lissajous figures is not there in the portion. I just showed you, like, just in case. You can get quite weird shapes. Energy of an SHM. Now, straightforward. First thing, the kinetic energy is half mv square. And we know velocity is half m omega square a square minus x square. Second thing, we know F is equal to minus du by dx. This comes from work power energy. And F is nothing but minus kx, the restoring force. So du is kx dx. Integrate on both sides. When x is 0, potential energy is u mean. This is u and this is x. You get u minus u mean is equal to half kx square. So we get potential energy u is equal to u mean plus half kx square or you mean half m omega square x square. How do we get that? We know omega square is equal to k by m. These are the main results. The potential energy, the U is your potential energy, Ke is your kinetic energy. Now, if I add these two, which is potential plus kinetic, you end up with half m omega square a square plus u mean. Now here, be very careful. This is where people mess it up. There are two things here. So total energy is half m omega square a square plus u mean. This component here is called oscillation energy. This is the energy which converts from kinetic to potential and potential to kinetic. So exam is sometimes they'll ask you find the oscillation energy and find the total energy. Both are not same. Oscillation energy is something else completely. We'll talk about that. It's like, let's say in your bank account you have 1 lakh rupees, but the minimum balance is 10,000 rupees. So how much money you can actually use? 90,000. But how much do you have? 1 lakh. Get the difference. Even though you have namesake 1 lakh, but the utility is only 90,000. The 10,000 minimum balance you always have to keep. Something like that. This U minimum, U mean is a constant value which does not change with time. What changes with time is only the kinetic energy and potential energy. Have a look at this page. Next thing. So let's write that at the start. Oscillation energy is half m omega square a square. This can be also written as half m v max square. This is also the maximum kinetic energy. So keep this in mind. Total energy and oscillation energy need not be equal. They can be equal. Not equal if u mean is not 0. If u mean is 0, then both are equal. Now, if you try to plot the graphs for this, we are drawing the graph with respect to x. Exam they did ask questions like this. They gave 3 graphs like this, and they said which graph belongs to which is potential energy, which is kinetic energy, which is total energy. The black one, the green one, and the red one. In this, who is potential, who is kinetic, and who is total? This is the case where U mean is 0. Total energy is constant, so the black line is total. And look at the green line. The green line, if you see at t at x is equal to 0, it is 0. At extreme positions, it is more. It's a potential energy. Look at the kinetic energy. At the mean position, the speed is maximum, so it will be peak, and kinetic energy will be this. This is the case when U mean is 0. So this is not the only graph possible. Kinetic energy so will look like this only. The potential energy can change. This is the case where U mean is greater than 0. This is the case where U mean is less than 0. So someone gives a graph like this, don't think it is wrong. You're just messing up with the U mean ka values there. Have a look at this. Now, if I try to draw the same graphs with function of time, x is equal to a sine omega t, v is a omega cos omega t. Potential energy is half m omega square x square is half m omega square a square sine square omega t. This is a potential energy versus time graph. It's a sine square function. The frequency is 2f. This is important, right? Because this will again come in 4 chapters. And this was a straightforward question. If the frequency of oscillation is 100, what is the frequency of energy oscillation? Means at what frequency the energy is changing. The energy oscillates with 2f. Think of like this. How many times in one oscillation you get maximum velocity? 2 times when you cross the mean position. That means kinetic energy is going to maximum and zero 2 times in one oscillation. Therefore, the body is oscillating with frequency f, whereas the energies are oscillating with 2f the frequency. This guy is half m omega half m v square. This will be a cos function. That's a good question. Find the energy oscillation. You will see this in multiple places. This will be cos square function. So basically, you reach the peak here at t by 2. This is t. So periodicity has become half. Have a look at this. And they can also ask you this: kinetic energy average, potential energy average is 1 by 4 m omega square a square. Reason, the average of sine square is and cos square is 1 half. Average of sine square theta, cos square theta is half. This is important. Huh? Let's say x is equal to 10 sine 10 pi t. So here omega is 10 pi, which is 2 pi f. So f is 5. So energy oscillates with frequency 10. This was a question. The same thing I can ask you in alternating current. I can ask you in waves. I can ask you in 3 chapters basically. Let's see a question. All got this? Any doubts on this page? So we have a system u of x is x square minus 14x plus 50. Mass is 2 kg. This is your potential energy. The total energy of the system is 50 joules. Find x mean, find V max, find amplitude, find time period, find oscillation energy, coordinates of the extreme positions. Let's get this. I give you potential energy as function of x coordinate here. Total energy of the system is 50 joules and the mass of the body is 2 kg. With this information, you need to find the x mean, V max, amplitude, time period, oscillation energy, coordinates of extreme position. Get them up. Okay. Yeah. Get them. Let's see. Yeah, right, Adrit Arjun. Get the rest. Try. I'll give another minute and then I'll show you. Everyone should try. Let's see. Now there are one or two ways to handle this. One, we know force is what? Minus du by dx. So if I differentiate this, minus 2x, 2x minus 14. But we know force is mass into acceleration. So 2 into a is minus 2 into x minus 7. So we can clearly see we get a is equal to minus x minus 7. This we compare with our equation a is equal to minus omega square x minus x. This is your general equation. This will directly give you omega 1 and x min is 7. If omega is 1, time period is 2 pi by omega. From there, you'll get your time period. If I got x mean, I can find u mean. U mean is simply when x is equal to 7. Substitute there 49 minus 98 plus 50. So that is 1 joule. And therefore, we also know what is total energy. Total energy is half m omega square a square, which is your oscillation energy, plus u mean. If u mean is 1 and total is 50, then the oscillation energy which is half m omega square a square is 49. This is half, mass is 2, omega is 1, and this is amplitude square. Amplitude is 7. This is one way to do. Another way is find the minimum value of ux. When the potential energy is minimum, kinetic energy is maximum. Isn't it? This is one way to do. Another way to do, right? Alternate. You can write u of x as x minus 7 whole square plus 1. You can clearly see when x is equal to 7, u is minimum. Therefore, u mean is equal to 1 and kinetic energy maximum is 49. Maximum kinetic energy is oscillation energy. You can play like that also. Either way it works. Both are the same thing. And if you try to look at the points here, this system, right, is oscillating like this. X is equal to 7 is your mean position. X is equal to 14 is the amplitude, and x is equal to 0 is another extreme. So the system is oscillating between 0 to 14. So the extreme positions are 0 and 14. Please have a look at this. The differentiating thing is the better thing, I feel. Easy? Got this? How did you get omega is 1? Comparison? 1 का place में omega square is there, right? This is your general equation, na? So compare these two terms. That omega, though, you need to get it from differentiation only. Clear with this? I hope you're getting the meaning of total energy and oscillation energy. Both are not same. So exam they ask you oscillation energy, don't write total energy and come. Next thing. So that is one thing about the equations. Next thing, the important thing. Now we will see how to find time period for systems. So if someone gives you a system and you need to find a time period, these are the steps. Step one, choose your system. And bring it to rest at mean position. Let's say the system is already oscillating, jumping. I don't care. Just stop it. Bring it to rest at the mean position. Valid for any type of system. Doesn't matter. Spring, block, that, this, rotation, everything. Second, after you bring it to the rest, displace it along stable equilibrium. You need to displace it, but if you displace however you want, it won't oscillate. Displace it in equilibrium position by X. What do you mean by that? Example, plus Q and plus Q. If you take a minus Q here, if you displace along the perpendicular bisector, if you observe, this thing attracts, this will be the F net. So this will always try to come back here. This is a stable equilibrium. No matter how much you push along the line, eventually it will try to come back there. But same thing, plus Q, plus Q. If you put a minus Q here, and if you try to displace it this way, what will happen? This is your mean position. The moment you try to push it this way, the attraction will become more. The right charge attracts more strongly than the left one. So it will not come back. It will just keep going towards right. It does not come back. This is an unstable equilibrium. So you have to be careful which way you're pushing it. If you push it in any way you want, it won't oscillate. Are you getting this? Stable and unstable equilibrium. So the same point can be stable equilibrium, same point can be unstable equilibrium, depending on which way you're displacing it. If you displace along the perpendicular bisector, it is a stable equilibrium. But if you displace it along the line joining the charges, it is an unstable equilibrium. Have a look at this page. Clear? Let's see. Third, so after displacing by x, find the acceleration as function of x. Fourth, compare this A is equal to minus omega square x minus x mean. When you compare, you'll get omega from there, and from there you get time period is 2 pi by omega. That's it. These are the 4 steps to find time period for any system which is in SHM. Let's see how it works. So let me take an example, simple one. We have a block, mass m, k. This is at mean position. Step 1, stop it. It is already at rest. So displace it by x along the stable equilibrium. So you displaced it by x. Draw the FBD. Forces will be kx. And remember the convention, we always choose acceleration in the direction of displacement. That is just a convention. If it is going forward, we think acceleration is also forward. We always choose A in the direction of displacement. And we know it is wrong, so automatically the sign will take care of it. The force is backward, acceleration is forward. So kx, force is equal to mass into acceleration. So minus kx, left is negative, right is positive, m into a. So we get a is equal to minus k by m into x. Compare this with our equation, a is equal to minus omega square x. Therefore, we get omega is equal to k by m. So time period will be 2 pi by omega, which is 2 pi root over m by k. I know this looks easy and all, but I'll show you. The same thing we can use in different things. Clear? Omega is root k by m, yes. Let me take one more example. Same thing, let's say the block is already hanging from the ceiling. Now, this is where you have to be careful. This is your natural length, but this is your mean position. Mean position is a point where the net force is 0. This is y. So ky is equal to mg. Now, step 1, bring it to rest. It is already at rest. Displace it by x from the mean position. And remember the spring force when you're at k into x, it is always from the natural length. So now if you draw the FBD of the forces, this guy will be k into x plus y. This guy will be mg and this guy will be acceleration. So we can write mg minus kx minus ky is equal to ma. But I know mg and ky will cancel. So we get a is equal to minus k by m into x. Compare this with our general equation, a is equal to minus omega square x. The time period is 2 pi root over m by k. From this, you can clearly see if you have one single block and one single spring, the answer will always remain same. The time period for oscillation does not depend where is your mean position. Are you getting how I'm writing the forces? Have a look at this. Let me give you one more example. Let's say we have a container filled with liquid and we have a cube here. Side L, rho B, and the rho liquid. It is at rest initially. So let's say this is Y inside. Now, if you disturb this, his block is slightly pushed and released. It will start oscillating. You want to try this? You can do this actually. Find time period of oscillation. Give it a try. So initially the block is at rest. Density of the liquid is greater than density of the block. So already some Y is inside. Now you pushed it by X inside and you released it. Now after this, I'll teach you one more technique where you can avoid actually few steps and get the answer much faster. This is what I was saying. It need not be always spring and block. I can bring everything. Later on, you will see. We'll get thermodynamics also in this. We'll have thermodynamics. We'll have rotation, fluid mechanics, everything. Meaning later on when we do surface tension, every damn chapter you can bring into this. Let's get this. Try everyone. Same steps. First thing, draw your FBD. So already your Y inside. So what are the forces? The buoyant force, which is rho liquid, L square, YG, and mg. This is at rest. Now push this by X inside. So you displaced by X and there's already Y inside. So we get the new buoyant force, which is rho liquid, L square, X plus Y into G. Mg will remain same. Acceleration. This is mg. And remember initially FB was mg only because it is at rest. Mg minus rho liquid L square X plus YG is equal to Ma. We can see that Y ka term and this term will cancel. You end up with minus rho liquid L square xg. Rho body is rho b L cube acceleration. We get A is equal to rho L g x by rho b L. This is your omega square ka term. The time period is 2 pi root over rho b L by rho L g. Did you see what happened? The entire question is fluid mechanics. End में SHM will come and say this is omega square. Yeah. have some patience. That's the next thing we are going to do. Clear how to do this? This is your general standard format. Gives you the answers and everything. But there's a much faster way to do this. Any doubts on how I did this? Now we can directly jump into a shortcut, but we should really know first what is happening, and then the shortcut will make more sense. Clear? Now the idea here is what I'm interested, right, is actually not the forces. What I'm interested is the force which is bringing you back, the restoring forces. So instead of drawing an FBD of the forces, we will draw an FBD of change in forces. The reason is, if the body is in equilibrium, think of like this. Let's say someone is pulling with 10 here and someone is pulling with 10 here. Now suddenly this became 12. Then what will you write? 12 minus 10 is equal to MA. But what I'm saying, how much did how much, the force change on the right side? 2. How much did the force change on the right side? 0. So what's the restoring force? 2 is equal to MA. The logic is making sense. End of the day, what you're interested in is the difference in forces, right? You don't actually want the actual forces. So if the body is in equilibrium, already the net force is 0. And now when you displace them, the forces will change. So when displaced, the net change in force is the restoring forces. And then you can simply write restoring force is equal to mass into acceleration. Let me show you this. So in our question here, so we have a spring and a block M. So this is your natural length. So already there is some force acting on the block. Now when you displace this by X, we can remember we are drawing only FBD of change in forces. How much did the spring force change? The spring force is changed by K into X. But technically, what is the force? K into Y plus X. I hope you're getting the difference. How much did mg change? We'll not write mg. Mg did not change, so we don't draw it. So acceleration, kx is equal to minus ma. There, we got the same answer. So when you displace it, just see how the forces are changing and finish it off. Let's take this blocker problem. The block is already there, rho b. Now when you displace it by x, when you push this by x inside, this part is already inside. This is that additional buoyancy force. This is the extra buoyant force. The blue one is anyway cancelling mg there. So again, FBD we write change in buoyant force. We don't write the buoyant force FBD, we write change in buoyant force, which is rho liquid, length L square, x, g. mg did not change, so we not write it, acceleration. So think of like this. The reason why we are not writing mg, if you see here, this mg and this thing will always cancel. That is what is actually happening when we take restoring forces. And now you'll get it, delta FB is equal to minus ma. Rho liquid L square xg is equal to minus rho b L cube A minus rho liquid L by same answer. Clear, Naditya? This is what you're saying. Yeah. This saves you time. How does it save you time? Think about it. Do I need to care what is the initial condition? This step goes off, na? I don't care what is the initial depth inside the water. I don't care what is happening initially. I do not care. I will just displace it and I'll see what are the change in forces and I'll take change in forces equal to m and you're done. The simple reason, think about it. The reason I showed you this is that only. They will always cancel. I want you to see this thing. They will cancel. That's why the initial conditions won't matter. What you're interested in is only the change. Please have a look at this. Clear? Next thing. Now we saw one spring and one block. Ka answer is 2 pi root or m by k. That's a standard result. Combination of springs. We have done this in NLM if you remember. If you have springs in series, they have same force. K1, K2. You can replace this one spring K equivalent. 1 by K equivalent is 1 by K1 plus 1 by K2. The springs in parallel, they have same elongation. K equivalent is K1 plus K2. What happens if you cut a spring? More about this we'll study in elasticity, but for now, let's say we have a spring of K in length L. If you cut this into two pieces, K1, L1, K2, L2, remember this, in a spring, the K into L remains constant. Example, you cut the spring in the ratio of L by 3 and 2L by 3. That L by 3 spring is K1, L by 3. So that will be K into L is equal to K1 into L by 3. So K1 will be 3K. So the shorter springs will have more spring constant. This is K2 into 2L by 3, which is K into L is K2 into 2L by 3. K2 will be 3K by 2. Check. So if you cut a spring, K into L is constant. Hope you remember this. NLM में किया था हमने. Y that is constant, we will see in elasticity. There we'll get something like K is equal to YA by L. Young's modulus, area of cross section, and all that stuff. We will see there. So when you cut, the area of cross section doesn't change and the Young's modulus doesn't change. Clear? Let's see a question. K1, K2. We have a block M. Let's call this point P. 3K, 2K, and 2K, and then. So find the time period. If block has amplitude A, that means if the block is going up and down with an amplitude A, what is the amplitude of point P? So meaning this block is going up and down with an amplitude A. So how much is this P going? Time period is easy. You can just take K equivalent and finish it off.
So in B part, we have to do only find the time period, right?
Time period only, yeah.
Okay.
Let's see. First thing, what is K equivalent? 1 by K equivalent is 1 by K1 plus 1 by K2. K1, K2 by K1 plus K2. The time period is 2 pi root over M by K equivalent. Here also, this can be written as 3K and 2K will become 4K. So here K equivalent is 4, 3, 12K by 7. So there you get the time period from. Now, if you look at this motion here, if you're saying this is going in amplitude A, let's say this guy goes x1 and this guy goes x2. We know x1 plus x2 is a, let the upper spring stretch by x1 and then let the second spring stretch by x2. And we also know because both are in series, k1 x1 should be equal to k2 x2. They're in series, right? The spring force will be same here. Point P is a massless thing. So from there, you can substitute here x1 plus x2 will be k1 x1 by k2 is equal to a. So x1 will be k2a by k1 plus k2. So whatever the upper spring will stretch, isn't that the same distance P will move? If the upper spring is stretching up and down by x1, point P also will go up and down by x1. This is the amplitude of P. The elongation in the upper spring is the amplitude of point P. Elongation in K1 is the amplitude. Clear? Check it out. Yeah, most of you did get right. Easy. Next one. Take a break. Come back by 7 to we'll continue from here. You can also find, yeah, it's the same thing. Find compression and subtract from A. And literally you're finding A1 only now, X1 only. Any doubt so
The
far? You can ask
amplitude
me.
of the P part,
Hmm.
it will depend
Hmm.
on the length of the spring, right?
Why? What is amplitude definition? Displacement from the mean position. Why do I care what is initial length?
It won't be proportional. So how much the second spring is there, how much first spring is there?
Why does it matter? What do you want to say? The length of the spring you want?
Yes,
Are you trying to measure the length from the natural length? Or are you measuring the amplitude from the mean position?
the natural length, are they equal or
Why
not?
will you measure from natural length? Will the system initially be will the springs are initially at natural length? If in this mean position, will the springs be in natural length?
No.
No. Then why do you bother? No, this might be the natural length, but this is the mean position. Now from this position, if it stretches by x1, point P will come here, isn't it? This is your amplitude, no? Makes sense. We don't care the length from the mean position. The amplitude definition is simply the displacement from the mean, not from the natural length. This is the case where mean position and natural length are not same, right, Adrit? For example, देखो ये example में इनिशियली दिस इज द मेन पोजीशन. अगर मैंने इसको x नीचे पुल करके छोड़ दिया, एम्पलीट्यूड कितना होगा? x ओनली ना, x प्लस y नहीं है ना. So why do I care what is the length of the spring? Clear? चलो, take a break, come back by 7 to.
So,
God.
so I sent you a question, so,
I know you sent me. बोलो क्या हुआ?
so I was not getting it. Like I tried.
सोचो आज का क्लास के बाद समझ में आएगा.
Oh,
When did you try? You tried before I taught you, ना?
no, sir.
First thing,
The test, and then I thought you have to do it similar to that first problem you gave, but then
नहीं देखना. First thing सुनो, क्वेश्चन में क्या किया. First ही cut the spring.
हाँ,
तो क्या हो गया? दोनों का स्प्रिंग कांस्टेंट डाला गया ना, गॉड K1 K2.
Oh,
तो दोनों को के ले लिया.
हाँ.
Then the question has become simply like block spring block ना, दो
Hmm.
springs था बीच में, दोनों को एक spring से replace कर लो. It's a two blocks in one spring.
Okay.
करते हैं ऐसा problem. We'll do today.
Okay.
Find time period for one oscillation. So we have a block here. In the first case, there are two springs. Second case, there are elastic threads, which behave like springs only K1, K2. Find the time period for one oscillation. Other scams on. What is the catch? No, Arjun, they're not in series. What is same, Ray? If it displaced by X, will they have same elongation compression or will they have same force? Right, Lakshika, you got it. And right, Anusha. See, the catch in this question, right? If I displace this by X, what is the force? This guy will push by K2X because it got compressed. This guy will pull by K1X because it got elongated. If you push this by X, this gets compressed. So it will push you back. This gets elongated, pulls you back. So if you see the restoring force, it will be K1 plus K2. X is equal to Ma. Actually, both are in parallel. Time period will be 2 pi root over M by K1 plus K2. What about the second one? What is the catch between a spring and an elastic thread? A spring can pull and push. But an elastic thread can only pull. Elastic thread or rubber band. They cannot push. So this system, if you displace this by x this way, this is what will happen. This side will become loose, isn't it? So there's only one force acting here, K1x. So this behaves as if there's only one spring. So this motion, right? So from here to here, it behaves only one spring is there. So this time will be T1, which is 2 pi root over m by K1. If there's only one spring. If you push it to the left side, then the left spring will become slack. So when it is coming on the left hand side, this motion ka time period will be T2, which is 2 pi root over m by K2. So the total time period will be, you're doing half of T1 and you're doing half of T2, isn't it? When you're on the right hand side, you're doing half of the oscillation with time T1 and half of the oscillation with this thing. So pi root m by K1 plus pi root over m by K2. The whole thing behaves as if there are two springs independent of each other. When you go to the right, the left spring won't work. When you go to the left, the right spring won't work. So you take half of each oscillation. Yeah.
Can you say that the springs are in series if their displacement has the same sign?
सीरीज में सेम फोर्स होना चाहिए.
Okay.
Have a look at this. It's a good one, huh? This elastic threads. We can play around with this question. What if there is one spring and one thread? Now what will happen? If it is one thread and one spring, what would change in the question? When you're going to the right, this will be right now. Now this will become spring also will push, isn't it? This will become K1 plus K2. Getting the difference? When you go to the left, it behaves like there are two springs now. Clear, everyone? So you can play like that also, one spring and one thread. Check it out. Any doubts on this? Perfect. Next one. Got it, na, everyone? Neil? Aryan? Arjun, clear, na? Adrit? Rehan? Malika? Great. We have a block here. This is the mean position. X is equal to 0. This is equal to x minus a, released from here. Matlab spring is already compressed. And here we have a wall, which is equal to x is equal to root 3 a by 2 and e is equal to 1. So what will happen to the block? It will go collide with the wall and come back again. So you're not letting it complete full oscillation. Technically, if it is minus a, shouldn't it go till plus a? But in the middle, you kept a wall. Find time period. How do we do this? Try, take a minute. Okay. Let's see. So the idea here is, if you look at the motion, you're going from x is equal to minus a, x is equal to 0. You're going to x is equal to root 3a by 2. And again, you're coming back. So remember last class I told you, remember the table. So from minus a to 0, the time taken is t by 4. From 0 to root 3a by 2, time taken is t by 6. T by 6 and t by 4. So the total time period will be t by 2 plus t by 3, which is 2t by 3. Which is 2 by 3. And what is the time period for one oscillation? 2 pi root over m by k. Isn't it? Because see, the moment this collision happens, this part of the motion is gone, isn't it? If you collide with speed v, you'll come back with speed v. It doesn't matter. So the whole system behaves as if, this part of the motion is removed. So you just have to subtract the time period from root 3a by 2 to plus a. Easy. So for this, you should have known this thing. So if you don't know this results, then this would have been difficult. There. Check it out.
So if E is not equal to 1, we can't say anything, right?
Then the block will keep on colliding multiple times, no? Then I can ask you another question. If E is equal to, let's say, 1 by 2, how many times will it collide with the wall?
So basically the energy will be like
Keep
will
on losing
using.
continuously, na? Yeah.
Okay.
So after colliding here, it won't come back to minus a.
Got it, yeah.
Clear with this? Next one. You have M and K, system is at rest. You took another block M and you attached it here. And released. So you made them stuck and then you released it. Find the time period and the amplitude. So once you stuck, what will happen? Because the weight becomes more, this guy will start oscillating up and down. Find the time period of oscillation and the amplitude of this system.
It's the amplitude of the new oscillation, right?
What is the old amplitude according to you then?
No, matlab like displacement from the new mean position, right?
Find the amplitude of the oscillation.
Arey.
Yeah. Time period is the easiest one. Time period doesn't care. Remember, like you just bring it to, no matter, even if it's oscillating, you stop it. So time period is the easiest. 2 pi root over m by k. M is 2m here. Amplitude is fun. Get that. See. So initially m is this. This is your natural length. Now the moment you attach the block, let's just call this thing, it became 2m. Remember, this is your old mean position, isn't it? And how much is this? This is mg by k. Now tell me one thing. The moment you attach the block, what is the velocity? 0. Now you tell me, during an oscillation, when will the particle have 0 speed? At the extreme position. That means this is the new extreme now. The moment you attach the block will start moving from there. The velocity is 0. It's a new extreme position. Since in an oscillation, velocity is 0 at extreme. So from here, this guy will now continue to move downward. This is your new mean position. What is mean ka definition? Net force is 0. So you measure it from the natural length. So this thing will be ky is 2 mg. So this y will be 2 mg by k. Now, if this is 2 mg by k and this is mg by k, then this difference should be mg by k, which is nothing but amplitude. The new distance between the new mean position and the new extreme position is amplitude. Make sense? If they ask you how much further will it go, I can do that also. It will go one more amplitude A down and stop. That will be the maximum elongation in the spring is 3 mg by k. Is this logic making sense? So since the particle here starts from rest, in an oscillation, the speed is 0 at extreme position. That's it. That if you use that logic, you'll get the answer fast instead of trying to use max and solve. Clear? Easy? Next one. We have a spring 2m and k. Hope you remember the speed. It is in center of mass. This is given speed u. This is at initially at rest. The ground is smooth. Find time period. Oscillation energy. Find amplitude of each block. Find maximum and the minimum speed of the blocks. Can you find acceleration and then relate to it? For which question, Aryan? Previous one. Try find the acceleration and relate to it. You can. It'll be the same thing. You're asking for the 18th one, right? Yeah. Same thing you'll get. Remember step 1, what you have to do, you have to bring it to equilibrium. So farak nahi padega where you want to start. This question you're saying. This I'm not sure how will you do. Get it. I know some of you know the result for that. Do that remaining 3 questions. I hope you know how you got that result. Let's see. First thing here, when the system is moving, there is someone who is not, not accelerating or not changing. Someone here is going with a constant velocity. Who is that? Center of mass. So if you go to the center of mass frame, if you just go here on the center of mass here, and if you go and stand there, what does the center of mass think? Now, what is the velocity of center of mass? Velocity of center of mass is mu by m plus 2m, which is u by 3. So center of mass will think this guy is coming with 2u by 3, and this guy is coming with u by 3. Agreed? Now, and remember, center of mass is an inertial frame. So there's no problem. I can stand there and do the problem. There's no pseudo force, nothing. So there is no pseudo force. Acceleration of center of mass is 0 since there are no external forces. So if you ask these two blocks, what will they think? The two blocks will think this point is fixed. Then the whole system behaves as if this guy is connected to this thing of length 2l by 3, and this block is connected to length l by 3. Isn't it? You can just cut the spring at the center of mass and treat them as two springs, and this spring constant will be how much? 3k by 2. This spring constant will be how much? 3k. So this time period will be 2 pi root over m by 3k by 2. This will be 2 pi root over 2m by 3k. Answer should come same. Now for this, the general result is, if you have m1, if you have m2 with a k, 2 pi root over, we write it as mu by k. Mu is called reduced mass. Which is m1, m2 by m1 plus m2. Do you remember reduced mass? To find that maximum spring compression, we did this thing. So this term pops up like again here. So we can just replace the whole system with one spring and one block of mass, m1, m2 by m1 plus m2. Again, how do we know this? We proved it, meaning it comes that way. When you cut the spring here, m1 and m2, the lengths will divide in the ratio of m2 is to m1, and from there you can figure it out. So if you have two blocks with mass m1, m2, and k, you can directly use this formula and get the answer. Check it out. Clear? What is the second part of the question? Find the oscillation energy and amplitude of each block, maximum and minimum speed. See, if you want the speeds here, you can clearly see these blocks are simply oscillating front and back. So after some time, this will go back with 2u by 3. This will go back with u by 3. So velocity of block m with respect to ground will be velocity of m block with respect to center of mass plus velocity of center of mass with respect to ground. So when do you get minimum? For minimum, both should be opposite. And for maximum, both should be in the same direction. So velocity of mass with respect to center of mass is 2u by 3. And that, see, center of mass velocity will never change. That is always constant, u by 3 I cap minus u by 3 I cap. This is your minimum speed. Max speed will be u only, the initial speed. And both are in the same direction. Same logic you can use for 2m also. Velocity of 2m with respect to center of mass plus velocity of center of mass with respect to ground. Now center of mass velocity will never change. So this guy will be u by 3 I cap plus u by 3 I cap. 2u by 3 I cap. This is your max speed. So 2m cannot go faster than 2u by 3. Minimum speed is 0 initially when it is at rest. Clear how to get the speeds? That's your maximum and the minimum speed. What else did I ask you? Amplitude of each block and oscillation energy. How to find amplitude? So this is your V max, no, with respect to center of mass. So V max is nothing but A omega. So for the first block, it is A1 omega is 2u by 3. For the second block, A2 omega is u by 3. Omega ka value you know. From here you get A1 and A2. Center of mass will think the maximum speed of the blocks is this 2u by 3 and u by 3. And V max is A omega. Omega is simply this thing. Omega is 1 by 2 pi root over 3k by 2. That is one way to do. Or you can find the maximum compression and you can say the masses will divide in the ratio of opposite ratio of the masses. That also will work. What else do you want? Oscillation energy. How do you find that? Clear? How to find the second part? Keep a space here. Do you remember this formula? Kinetic energy of a system is kinetic energy of center of mass plus kinetic energy about center of mass. So I can do that. Kinetic energy of system is kinetic energy of center of mass plus kinetic energy about center of mass. If you see here, so this is half total mass 3m V center of mass square plus kinetic energy of center of mass. Remember how much is this? Half m1 m2 by m1 plus m2 V relative square. Basically, this is your maximum compression energy in the spring. Think about it. In the system, right, there are two energies, isn't it? The kinetic energy, this is constant. This will never change. So the total energy has two components. There is one constant component and there's one component which is changing continuously. So basically, this energy changes from spring to kinetic and kinetic to spring. So this is the component which changes. That's your oscillation energy. And in case you forgot how we got that, center of mass collision. There, page 99. That's your energy there. So basically, you can split the energy into two parts: a constant energy, kinetic energy of center of mass, and about center of mass. So the oscillation energy is that component which changes from spring to kinetic and kinetic to spring. So in our case, it is half m1 m2 is 2m by 3, and V relative square is u square. Check it out. Hope that is making sense. Clear? Next one. Any doubts on this? Rehan, Swastika, clear with this? Vidyut, Palaksh, Aryan, Arjun, Anika?
Yes, sir.
We have a spring here. M 120 degrees, 120 degrees, and 120 degrees. Block is slightly pulled down and released. That is important, slightly, because if you pull it too much, the angles will change. So when they use the word slightly, you are assuming the displacement is so small, we can still assume the angle is 120 degrees. Pulled down and released. So basically, this statement says assume the angles are almost constant. You can neglect the small change. Find diameter. Just give it a try. Some water in come. So how to do this thing? Whenever you have springs at angles, right, you can do something. So let's say we have a block here, M. We have a spring here, and let's say this is theta. Now, if someone displaces the thing by X this way, the first thing what happens? If you displace this by X, this spring will get compressed by X cos theta. Compression or elongation, whatever. Component basically. So if you try to draw the FBD of this now, the spring is pulling with Kx cos theta. But you want the force in the horizontal direction. So the horizontal component will be K cos square theta into X. So you can replace this whole setup with a block and a spring whose K equivalent is K cos square theta. Again, valid only for small theta. Valid for small x. So that you can. So two things will happen. When you displace by x, the spring will compress only x cos theta, and the force will be again kx cos theta ka cos theta. I hope you're getting that. So coming back to our problem now. So M. This is 60. This is 60. You can replace this with a block M. This will be K. This will be like two springs, which will be K cos square 60 and K cos square 60. And here we can see K equivalent, everything adds up actually. K plus K by 4 plus K by 4. 3K by 2. Time period is 2 pi root over M by 3K. Actually, if you solve now, here also use the same logic. Displaced by X. Then this compression will be X cos 60, X cos 60. Then we will see the force is Kx by 2 ka cos 60, Kx by 2 ka cos 60. Same thing, I just showed you with a general theta and X. So clear? Next one. Any doubts on this? Next thing, how will the trajectory look? What are you asking, God? What trajectory are you talking? It is displaced down and released. It will just go up and down. Question that is just displaced by down and released. So why will it go in any other path? Next thing. Spring constant K. This is a massless platform. We have a block M here at a height h. This is released from rest. Find time period. This is a good one, right? This is a proper advanced question. Let's see what you guys will do. Let's finish off last one for the day.
So the block sticks to the platform, right?
Why does it matter? Why should it stick? It is a master's platform.
I mean, like, okay.
Ever jump down a trampoline? You stick to the trampoline. If you're jumping on a trampoline, do you stick to the trampoline? It'll be quite weird if you stick to the trampoline. I hope everyone got the motion. What happens here? The block comes, falls on this thing. The spring will compress, then the spring will push it back. Again, the block will fly in the air. Na? The block is simply, it's just like jumping on a trampoline. You fall, spring compresses, the spring will push back. This platform will be here only, but the block will start flying in the air. Let's see how will you guys do this. That is a trap, Adrit. You did jump into the trap. I know you forgot a route and stuff, but still, it's messed up. Let's see how many will fall into the trap. Think. I'll give another 2 minutes. Like I keep saying every time, if you can actually figure out what is happening with the whole motion, you'll understand the question. Don't jump into getting the answer. Wrong, Lakshika. That is wrong. You also fell into the trap. Aryan, wrong. That's definitely wrong. You got something totally weird. Anika, what did you do? What is X? What is that? You dug a new trap and you jumped into it yourself. ये तो अलग ही है. I don't know what is this. ट्रैप भी नहीं है ये, कुछ अलग ही है ये. नहीं Palaksh. Where the hell are you guys getting X from? X क्या है? Meaning you writing X and X. What is X exactly here? X? Let me show you the thing. What is happening? You don't care about X. The time period of a spring block system does not depend on the compression, isn't it? अभी तक बताओ, in which problem did you see time period depending on the compression or the amplitude? The mistake you guys are doing is this. Block of mass m, this is your initial position. This is the natural length. So the block will come and fall from here to here. Let this be time t1, which is root over 2h by g, basic kinematics. Once the block hits the spring, this is a mistake you guys are doing. You thought this is your mean position. Ye mean position nahi hai. This is your natural length. And you're entering with some speed v here, which you can calculate. Root 2 gh. Now the spring starts compressing. At this position is your mean position, where this length will be x is equal to mg by k. So from here to here, the time will be t2, which I don't know. Then the block will continue to go further and finally stop. This is your extreme position. This would be your amplitude, and this time would be t3, which is t by 4, which is 1/4 of 2 pi root over m by k. Are you getting the problem? Most of you messed up this part. You thought this natural length is the mean position and you took this time as t by 2, isn't it? So the total time period for this motion will be t1 plus t2 plus t3 ka 2 times. Now here I know t1, I know t3, I don't know t2. T2 is the catch. And how can I find t2? X is equal to a sine omega t. So if I put x ka value is mg by k, amplitude, this would be sine omega t2. So from here I get t2 will be 1 by omega sine inverse mg by ak. Perfect. But isme omega to I know. Omega is root over k by m. I need to find amplitude. Amplitude we don't know. If I can find my amplitude, my job's done. You get in the motion here? When you let x is equal to a sine omega t, remember this x is the displacement from the mean position. So you have to find this time. So this is a small, SHM ka small part. How to find amplitude? We can find amplitude by loss in potential energy is gain in kinetic energy. This comes from work per energy. Loss in gravitational potential energy is gain in spring energy. Because initially you're at rest, finally also you're at rest. So the block has fallen at total height of mg, h plus x plus a. That should be equal to half k x plus a whole square. The compression is from natural length. Solve this and you'll get a value. I didn't give you numbers, but numbers are given, you would have got this. So this would be your final answer. Root 2h by g plus 1 by omega sine inverse mg by ak plus 1 by pi by 2 root m by k. If this question comes in the exam, people who figured out that there are 3 parts, T1, T2, and T3, you'll be able to eliminate all the 3 options. Because there'll be definitely one option where the answer is T1 plus T3. Isn't it? They'll ignore the T2 part like you guys did. That will be a trap. Please check what we did. So initially when you're falling and hitting the platform, it is kinematics. After hitting the platform, remember that's a natural length, that is not your mean position. So natural length to mean position, you will travel some distance xmg by k. So that you have to find the time period using x is equal to a sine omega t. And from mean position to extreme position is t by 4. That's why I know 1/4 of 2 pi by root r m by k. and double this because it'll go back again. Good one. Check it out. This would be a proper advanced question. Have a look at this. So that's the last one for the day. So next class, when we catch up, we will do more problems on springs, right? And then let's see if time permits, maybe we'll start off with the rotation introduction, angular SHM. It's not a big chapter, but it has a lot of varieties. If you see, it has quite a lot of variations. We should be able to wrap up the chapter in another 2 to 3 classes. Mostly 3 classes should be done with this. Clear? So we have done almost like 21 problems. So make sure to go through them once. I'll catch up again next Wednesday as usual at the same time. So any doubts, anything, stay back or also free to leave. So take care.